Hiya, I am just going to talk you through the linear search standard algorithm that you need to know about for hire. So first of all, remember the point in a standard algorithm, is just that it's a sort of well-known solution or a ready-made solution to a common programming problem. So you don't have to come up with it all the time. So standard algorithms are here to help you. So if in the exam you have to write an algorithm, or in the coursework you have to write an algorithm, it'll likely be based on one of these standard algorithms. And if you're familiar with them, then that'll help you. So the point of linear search is just, if you're given a list, an array of values, whether they're strings or numbers or Boolean values, it's just to determine whether a particular value appears in that list. So what do we have to do in order to do that? Well, we just work through the list sequentially, work through it one at a time, and we check each item to see if it's what we're looking for. And if it isn't, then we keep checking. That's the basic idea here. So I've got here a real basic linear search for you. In fact, it's even slightly more complicated than we need to be. Just written in pseudocode here. So basically, we begin by getting a target from the user, getting them to type something in. What are they looking for in the list? But we wouldn't necessarily be doing that. So that's a totally optional part of the algorithm. You might know you're looking for negative values, so you want to check if there are any negative values in this list of numbers. You want to check if there are any 5-letter words in this list of words. So you might not need to get the target from the user. We then loop through each item in the list, each item in the array. We check to see if it's what we're looking for. Then, well, we do something. So you might want to just display some sort of message every time that it's found. You might want to do something else. Maybe you want to go through the list, find all the numbers over 100 and add them onto a total. So it would be like total equals total plus the current item would be what you're doing there. So there are all sorts of things that you might choose to do. The condition might be something else. So it might not be checking if item equals target. It might be checking, as I said, if item is greater than 100. If len of item equals 5. If, examples I've got down here. If the item is not equal to 0. All sorts of things you could check. But the basic idea is the same. This is the key of it. We are traversing an array, looping through an array, and if we find what we're looking for, we do something. That's it. However, that's the most basic idea of linear search. Sometimes we need something slightly more complex. Remember, the idea here as well is that we can adapt this to fit all sorts of situations. So if you're familiar with this idea, then it should be easily adaptable. However, what happens here if we are looking for something and it's not in the list? Well, nothing. If it is in the list, we get found, and in fact, in this case, we'll get found every time it appears. If it's not in the list, just nothing happens. So, do we know if it even worked? So sometimes we might want to do a slightly more user-friendly version, depending on what we're trying to do. So here's an easy way to make it more user-friendly. So that's the basic linear search we just looked at. We used a new variable, what I would call a flag variable, because it is just being used to flag something up. Boolean variables are often used in that way, just to flag up whether something has happened or not. So we say at the start, I'm calling it found. We set it to false at the beginning. Okay, we haven't found what we're looking for. Obviously, we haven't started looking yet. And same as before, we may or may not be getting target from the user. And then we're going to replace, instead of sending found to display or adding whatever the item is onto the total or whatever it is we're doing, we're going to do this specific thing. We are going to flag it up. We're going to say we found it. So we're going to set found to true. So that's the key idea here. It's really similar to what we had, but specifically we are going to store in a variable that we have found it. And then that means at the end, so in terms of user friendliness and improvement on the last one, we can do specific things based on whether it is found or not. So without this, we did something if it was found, but nothing if it wasn't found. Here we just, if we know it was found, then at the end we can do different things, whether it's display a message or go and do different subprograms or whatever. Okay. This is a bit more user friendly potentially, like particularly for displaying things for the user to see, but potentially extremely inefficient. So we might be dealing with lists of 5 things, in which case this isn't a big deal, but we might be dealing with lists of 50,000 items of data, in which case there's a particular situation where it's going to be very inefficient. If you haven't thought of it, it is the fact that we might have whatever we're looking for appearing very early in the list. What if it's the first thing in the list, and at the moment we just go through all like 50,000 items of the list anyway? So first thing, set it found to true. Oh, I found it, but then we'll keep going. It's like if I give you a book and say, can you find if the word elephant is in that book? If the first word's elephant, you're going to stop there. You'll say, yeah, I found it. It'd be ridiculous to then keep going, looking through every other word just to check if elephant was there. You've already answered the question. So this is potentially very inefficient. So how do we solve that? Well, there's an easy way. At the moment, we're using a fixed loop. We just go around for however many items are in the list. Why does it have to be a fixed loop? Why not just use a conditional loop and just keep going until we find it? So here's my more efficient linear search, the ultimate version. So there's my algorithm that I was just showing you, for the more user-friendly version. So here's how I would change it. I would ditch the fixed loop that we had, and we're going to replace it with a conditional loop. So what do I need to do here? We're going to have a counter variable. We're going to have to make our own counter variable. In fixed loops, it's just part of it. Like if you do for I in range, whatever, then I is just automatically counting it. We're going to have to do our own one. So kind of manually set one up and then increment it as we go through the loop, add one to it. And then really we're just checking the start of each loop. We're checking, is found still equal to false? And have we not reached the end of the list yet? If that's the case, then keep going. Okay, so just, that's it basically. While we haven't found it and there are still things left in the list, keep going. And then this line here moves it on to the next item, adds one to counter, so it loops back round, checks again. Is found still equal to false? The counter still less than however many items are in the list? If so, then check this item. If it is, found true. Okay? That is it. Basically, all 3 of these ideas could potentially be useful to you. This efficient one, even the basic one at the start. If you're familiar with these ideas, then you should be able to adapt it. I like to just think, I mean, it's certainly great if you can memorize these, but I think key is sort of understanding of what's going on. And the basic idea is a loop through the list, and each time through the loop we are checking to see if the current item we're looking at meets a particular condition. And then if it does meet that condition, we do something. Maybe setting a flag variable like found to true, or maybe displaying a message, or maybe adding whatever we found onto a total, or anything else. Okay, hope that helps. Yeah, see ya.